Today we have got a very unusual limit problem, and it was a part of one of the very prestigious examination. Let's see how we can tackle this problem. So the first one is limit n tends to infinity GCD of 1 6 plus GCD of 2 6 till GCD of n6 over 1 plus 2 till n. And the second one is the same problem with LCM. Now, as all of you know, what is GCD is greatest common divisor, which is also called SCF, highest common factor. So what is GCD of 1 comma 6? Of course, the divisors of 2 is 1, 2, 3 and 6, and divisor of 1 is 1 itself. So the common divisors of 1 and 6 is 1, hence greatest is 1 itself. Similarly, GCD of 2 and 6 is 2, GCD of 3 and 6 will be 3, 4 and 6 is 4, 5 and 6 will be 5, and 6, 12, 6 will also be 6, 18, 6 will be 6, and so on and so forth. So all multiple of 6 will have a GCD with 6 as always 6, right? Now any number n can be written in the form of either 6k or 6k plus 1 or 6k plus 2 or 6k plus 3, 4 or 5. Because you take any number, you divide it by 6, the only possibilities for remainder is 0, 1, 2, 3, 4, 5. Hence let's take n equals in one of these fashions. So if we'll take in general GCD of, so I'm using a symbol of this bracket to use GCD to save time. So if we'll take GCD of 6k plus 6, we are going to get 6. 6k plus 1 will give 1, 6k plus 2, 6k plus 3, 6k plus 4 and 6k plus 5. Right, so if we'll add all the GCDs from starting from 6k to 6 number n in the form of 6m plus something, because any number n will be either divisible by m or it might leave the remainder of 1 or 2 or 3 or 4 or 5. If it is leaving remainder 6, it's definitely divisible by m. So any number n can be written as either 6m plus 1 or 6m plus 2 or 6m plus 3 or 6m plus 4 or 6m plus 5. So in general I can write any number n as 6m plus something, right? So here I have taken k, where k can take the values of 1, 2, 3, 4, 5. Now when we have n equals 6m plus m, so basically we can group these numbers in m boxes and something will be left, right? You think of a number, let's say 13. So 13 can be written as 2 box containing 6 element, and then we'll have 1 element left. So if that number n itself is a multiple of 6 m, so basically m boxes containing 6 item each, and we have k the leftover boxes. Now leftover boxes can have, of course, the possibilities for items in leftover boxes can be 0, 1, 2, 3, 4, 5. Now every box contains the sum of 15, so we have 15 plus 15 plus 15 m times, and then some leftover boxes sum. So that will be a finite sum because it will come only from 0, 1, 2, 3, 4, 5, 6, 5, right? So let's call that finite sum to be lambda. So lambda can take a value of maybe 0 plus 1 or 0 plus 1 plus 2 or 0 plus 1 plus 2 plus 3 or 0 plus 1 plus 2 plus 3 plus 4 or till 5. So anyway, this is finite number, a small finite of course. And similarly, if you are going to, let's say 19, if n is 19, so you will have basically 3 blocks of 6 plus 6 plus 6 chunk, and then 1 left over. So this is also finite object. Just now we'll put the value of n equals 6m in our limit, and what we got, since every box contains 15 sum, so we have 15 times m plus lambda over 6m into 6m plus 1 by 2, sum of numbers from 1 to 6m. And now you can see this limit is 0 because the leading term here in the denominator is 18m square, and we have a leading term in numerator is 15, so it will become 15 by 18m square, and m cancel, m tends to infinity, it will die. So the answer to the first question is 0. Let's start the second question with respect to LCM. So again, first let's play with the question. LCM of 1, 6, 2, 6, 3, 6 and so on. So LCM of 1 and 6 is 6, 2 and 6 is 6 because it's lowest common multiple, right? LCM of 6 and 6 will be 6, 3 and 6 will be 6. So from 1 to 6, LCM will be 6. What about 7 and 6? The LCM of 7 and 6 will be 28. Sorry. What about 7 and 6? So LCM of 7 and 6 will be 42 because they are co-primes. LCM of 8 and 6 will be 24. 9 and 6 is 36. And you have 10 and 6 is 30. And 11 and 6, again clearly we can see, will have 66 and so on. So there is no definite pattern here, right? It's arbitrary, we are getting a number. Of course, there is a pattern which you have to see when you put in the number form. Because let's say when you talk about LCM of 8 and 6, of course, it has 2 as a factor and 6 has 2 as a factor. A beautiful way of finding LCM of 8 and 6 will be product of numbers by their SCF. So it's 8 into 6, which is 48, and SCF of 8 and 6 is of course 2. That you can even derive from the previous result. Okay, similarly, SCF of 9 and 6 is 3. SCF of 10 and 6 is 2. So like this we can find. Okay, so product of number by SCF is going to be LCM. Anyway, so again any number can be written as 6k plus 1 form, 6k plus 2, 6k plus 3, 6k plus 4, 6k plus 5 and 6k plus 6. If, in fact 6k plus 6 is back to 6k. So here I am not writing 6k form. Just for the sake of different approach, I have given you a different format of writing these numbers for both problems. Now, what about LCM of any number which leaves remainder 1, which means any number which is in the form of 6k plus 1 and 6. So you can clearly see it will be in fact product of number divided by SCF. So product of number is already this divided by SCF. So SCF of 6k plus 1 and 6 will be 1 because they are co-prime. So hence LCM of this is just 6 into 6k plus 1. Similarly for the second one, the SCF of these number is 2 because 2 is the only common factor. Okay, so that's why we are just multiplying these two number and dividing by 2. So that gives 6 into 3k plus 1. Similarly for the third one, LCM of 6k plus 2 comma 6, you can tell product of numbers divided by their SCF. And now what is highest common factor between 6 and this? The only available factor for 6 is 2, 3. 1, 2, 3, 6, right? And the highest common factor from this, you can clearly see this is not divisible by 3 in general. So we are having 2. So we'll just divide it by 2 and that gives you 3k plus 1. Right, so on and so forth. You can just repeat the same for this and you'll get for next item 6 times 2k plus 1, for next 6 times 2k plus 2, 6 times 6k plus 5. Anyway, this is already co-prime, so this product, and 6k plus 6 and 6 will be just 6k plus 6 because it's already a multiple of 6, right? So which can be written in this one. If I add all these LCMs, so if I start from any number having remainder 1 and you go to a number having remainder 0, the sum of all these LCMs will be 126 plus k. It's basically just adding this, guys, right? So sum is 126 plus k plus 66. Again, as usual, we'll take n as 6m plus k, where k can take a value of 0, 1, 2, 3, 4, 5. And it doesn't contribute to the limit because when we are taking the limit of m tending to infinity, this k is finite thing. So anyway, while finding limit, the leftover is being divided by m. So it's better we can just omit it in the very first step also. If you want, you can, include this, but it doesn't anyway impact the limits as we have seen in the first problem. So now, basically the question was LCM of 1, 6, 2, 6, 3, 6 and so on and so forth. So similarly, we'll divide this entire problem into a box of multiple of 6. So let's suppose if we have m boxes. Suppose if we have m boxes 1, 2, 3 and so on and so forth. So every boxes will contain numbers leaving remainder 0, 1, 2, 3, 4, 5, right? Similarly, other box 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. So basically we need to add 126k plus 66, which is the LCM of any number starting from 0 to 5 with remainder. And this how many boxes we have to add like this? M boxes, right? So if I'll decode this, basically what I'm telling, if you'll see LCM of 1, 2, 3, 4, 5, 6, so that we are writing here, and answers we are adding, plus again LCM of 7, 8, 9, 10, 11, 12 we are adding here, plus LCM of 13, 14, 15, 16, 17, 18, we are adding here, and so on and so forth. So we have m boxes. So basically this can be written, this summation of boxes can be written as a compact form, which is 126k plus 36 adds the LCM of any 6 consecutive numbers. And now we have to run the operation from k equal to 1 to m, and some leftover will be there. Similarly in denominator, n is 6m plus something, so 6m plus some leftover. Now this leftover we can actually ignore, because anyway when we are dividing with the power of m or m square, it's going to die, right? So this summation, now it's sigma 126k plus sigma 66 will give 66m plus 63m into m plus 1, and denominator is same as before. And if we'll simply evaluate this, we have 60, maximum leading term is 63m square, and we have leading term from the denominator is 18m square. So basically dividing by m square, a usual ritual of limit, will make it 0 because m is tending to infinity, and hence the answer is 63 by 18, which is 7 by 2. So you see like how beautifully a concept of limit is connected with the ideas of basic number theory of LCM and HCF, and these problems are very important for JEE Mains and Advanced specifically. I hope you must have enjoyed the lecture. Keep yourself tuned.